Today we will introduce a little bit about ITO glass. What is ITO? Actually, ITO is indium tin oxide. Actually, it is a transparent conductive film. Um, so we use this transparent conductive film um, with two layers of the LCD glass. So in that case, we can build LCD cell. But if we look at the structure of the ITO glass substrate, we will see that the substrate actually is a soda lime glass. It is a very cheap glass, so it is easy to manufacture to make it flat. So in our passive LCD glass, so we still use a soda lime glass, but with a TFT that will be different. That is because soda lime glass has of course have a lot of sodium ion. Uh, it can be easy migrate into the liquid crystal material. So in that case, to increase the current. But for monochrome LCD, it is okay, still okay to use soda glass, but we have to put very high density silicon oxide dioxide to between the ITO and sodium glass. So in that case, to prevent the migrating of the sodium ion getting to the liquid crystal materials. But sometimes, with a strong alkaline solution, the silicon dioxide film can be damaged. So in that case, that will cause the problem for the high current for the LCD. And we can see that depends on the how big of the LCD and how high of the resistivity of the ITO film we are going to use. If the display pattern is very high density, so we need to use a lower resistance. Otherwise, we will cause the display non-uniformity because if the long layout, so at the end of the layout, so the voltage can be pretty low. So in that case, there is no enough voltage to drive the liquid crystal material. So that will cause a non-uniform display. So we will try to avoid that. But this table we can see that, of course, the ITO coated glass. So normally in passive LCD, so we use 14-inch by 16-inch. That is a pretty standard, industrial standard glass substrate. And then for passive LCD, we have 0.4, 0.55, 0.7, and 1.1 minimum thickness. And but for TFT, because it is a pretty bigger, so we use a very thin ITO glass. Normally we use 0.3 or even thinner glass. From this table, we can see that the higher of the resistivity, the transmission also higher. So that's because the ITO thickness getting thinner. So, but most of the case, we will use 80 to 100 ohm per square. Okay, so this is a actual. Okay. So normally we use 80 to 100 for normally TN LCD. So the transmission is pretty high. It's 87%. But in some high density display, sometimes we have to use 10 ohm square and 15 ohm square. So the transmission will be much lower. And of course, the cost will be low. So in that case, we need to calculate what is the lowest highest resistance we need to use. So in that case, we can get a cost-effective LCD. So and also we see that if the lower of the resistivity, the lower of the transmittance, the easier to get to see the ITU reflection in the LCD cell. So that will be ugly. Okay, so when there is no power on the LCD, but we still can see the segment of the LCD, so that is not good looking, and also higher the ITU glass cost.